This is a clap on, clap off switch. Some we call it clap switch, some we call it sound to light. Sound to light because the output is LED, that is light emitting diode. A clap switch circuit uses an Electret microphone in the circuit to detect sound to turn the LED on. Yes, I use LED as the output, so it will detect the sound in form of energy, and that will serve as the input to the microphone. Then the output will be the LED. This type of clap switch circuit can be used in our homes, in our offices, to turn on appliances such as lights, TVs, or whatever is set up to the clap switch. This one is just telling us that we can use, just as the simple circuit here, we can use an LED, that is the light emitting diode, the white one I use as the output. We can use it to drive a TV, you can use it to drive a fan, you can use it to switch it off and to switch it on. So you don't require a physical switch. In many cases, you can snap your fingers, clap your hands, speak or whistle to it, and it will come on. I want to tell us that, our voice, the claps, when we tap our fingers, they are varying frequency. Like when you clap your hands together, the frequency ranges between 2200 Hz, as I've read, to 2800 Hz. So if the electrolyte microphone can pick the sound, then you are good to go. That is the light. Then the components I use here, I use CD4017 is a CMOS decade counter. The CMOS means complementary metal oxide semiconductor. It's a type of semiconductor that was used in fabricating the IC. IC means integrated circuit, and it's used in different applications. The decade counter IC have 10 outputs. You will see in the coming slides, and counts from 0 to 10. That is the output comes from 0 to 10, and similar to Johnson 10 stage decade counter. This IC finds its usage in designing LED-based circuits, traffic lights. Yeah, it finds its application in the design of traffic lights and in driving some LED when you connect some light emitting diodes at the output from 0 to 10. Yeah, it will give you some beautiful lightings. So this is the 4017. This is type 4017. When you pick an IC, you will see this black dot. At least you can see the mouse cursor. You see this black dot, and you see something like a semicircle. Yeah, so this is where you start counting 1, 2, like anti-clockwise. That's how an IC is labeled, or the pins are counted. This one is a 16 pin IC. So you count anti-clockwise 1, 2, 3, 4, 5, 6, 7, like that. Yeah, and you can see the output. The output are labeled Q. You can see 0, 1, 2, 3, up to 10, or up to 9. So those are the VDD is connected to the positive supply, and the GND means ground. 8 is connected to the negative supply. And this is the configuration of the IC. You can see the output, you can see the GND output, carry out, enable the clock, and if you want to reset, pin 14. So that's basically about the 4017 IC. If you want to know more about the 4017 IT and 4017 IC and how it's being used, you can Google it and see the data. So this is Electret microphone. An Electret microphone is a condenser microphone used to convert sound into an electrical signal, and they are used in wide variety of consumer electronics such as mobile phones. That's where you find the application in mobile phones. Yeah, it's used as a mouthpiece in mobile phone, GPS divided, speech recognition equipment, our tablets, our headsets, our Bluetooth headset, the hearing aids. So they are most useful in those places. And this is the type you see it. Yeah, some may be smaller than this and some may be bigger than this. This is the basic circuit diagram. You can see I use the LED as the output here. I use LED as the output. Can you see? And in one of the first or second slide, I made mention that you can use the circuit to drive maybe your TV, just to switch it on. You can connect maybe a fan at the output, but I use an LED here, white LED here as the output, and this is the input. Yes, this one is the one that converts the sound energy, yeah, into an electrical signal. and we have an output there. So this is a simple circuit. You can get the IC, get the LED, and get the resistor and the electrolyte microphone. Then you are good to go. This is the testing board. I use a 9-volt battery. This is the IC, and this is the LED. These are the resistors. This is basically the circuit. So the next slide is talking about the video.
The circuit is arranged on the breadboard for testing. As you can see, the LED, that is the light emitting diode, that white component is used as the output. I've said earlier on that you can use this circuit to drive maybe a TV, maybe a fan. You want to switch it on, you want to switch it off. And mind you, the mic can capture some certain frequency. And I think if you have a bigger mic that is bigger than this, it will be of an advantage for you so that it will be able to cover a wider surface. Let me put it that way. So now if you clap, it generates some frequency. So if the mic can tap that frequency, then the light will surely come on. You can see that it comes on. You can see that it comes off. So the circuit is working perfectly. And I want to hit a table, maybe it will come on. You can see it came on. So it can actually tap, and you can see it comes off also. So the circuit is perfectly working, and you can connect different outputs. You can try a fan to drive it. I don't have a fan here, so that's why I'm not using it. Thank you. Now I want to try and connect a speaker at the output, removing the LED. Maybe it will work. Just to test another thing at the output. And I believe it should work if the clap can generate that frequency. I believe it should work. Please hold on a bit. Just find this. Okay, let me try and clap. Maybe it will work. No, it's not picking it. This is it. You can see? You can see? It works. You can see it works. Good.
Thank you. Please like, comment, and subscribe for more tips on do it yourself projects. Thank you very much for listening, and please stay tuned for the next project. Thank you very much.